Hello, and welcome to the first awkward recording. Hopefully they'll be getting better. So, before we get started, a word about these PowerPoints. These PowerPoints I did not make. They're made by a man named John Frensley, who has trained me and works for several different organizations involved with preparing for physics at all levels. So, with that, let's start the basics of motion with our essential question: how do we communicate an object's motion? Remember, as we go through this video, I'm going to be speaking fast, faster than I would in class for sure. You can adjust the speed. You can slow it down, speed it up, do what you need to do to feel comfortable. You can also rewind. So I know you're writing stuff down as we go, so hit pause, write down whatever you need to do. Just please follow along, pay attention, and if you have questions, write them down in the margin on the side. And then after you're finished watching the video, call me over and we can talk about it, clear some stuff up. Okay, so our objectives for this first video: we're going to define vector, scalar, distance, displacement, and the difference between those, speed, velocity, and the difference between those two. I thought they were the same thing. Understand the difference between average speed and instantaneous speed. If you want further reading, you can go to this website. It's the OpenStax College Physics book. You'll see that on my website or a link to it. You can read pages 35 through 45 to go along with this if you want further. So, our table of contents. If I'm scrolling super fast through these slides, it could be that there's a reason for it. It could be that there's something in there that we don't need to cover. But as we go through these slides, here's our best practices. If you're looking at these through a shared link, present the slides because there's animation, so you don't want to miss anything. You're not going to become a professional physicist by watching these videos. Okay, it's just not going to happen. This is just touching the iceberg, and then we'll deepen our understanding through our investigations and through our practice problems. Without doing the practice problems, you're not going to understand anything. Instead, we're looking for a basic understanding, very superficial. We're not going to be spending minutes on slides. That's kind of up to me. Don't keep rewinding something. Try to get the gist of a slide, and if it seems like it's just not clicking for you, write down your question in the margin. Call me over when you're finished watching. We're going to try to spend up to 30 seconds and not anymore. You have pre-printed notes that we're going to use with this. So with these notes, I want you to answer the questions, and again, pause if you need to. If you think you're getting it, you can skip ahead a little bit. Just make sure you have all of your questions answered, because based on those questions, that's what's going to help me determine where you are before we move on to another assignment or another lesson. If you're getting bored, stop reading whatever section and going forward. Sometimes it helps to skip forward and look at something new, because oftentimes we'll be covering a wide range of things in one lesson. The example problems, we're going to be working together, so you don't have to fully do it on your own, but my hope is that for each problem you will pause the video and try each problem before we go over the solution. All the slides are going to start with a guiding question that's going to connect everything in the slide. Guiding question appears at the bottom of every slide. Oh, I'm recording so we can't see it. Sorry. All slides start with vocabulary preview. Don't expect to understand vocabulary words perfectly from the preview. Just give it a skim to plant the seeds in your brain. These slides are meant to be skimmed. That's why we're going through them quickly, just for a basic idea. And as we go through our investigations and practice problems, cooperative learning, you'll start to develop a deeper understanding. If you're absent, then make sure that you're writing down those questions and addressing them with me when you get back, so we fully understand. Alright, so each slide has a section. I've seen an example. Don't worry about the example. Alright, vocabulary preview. These are some of the words that we're going to be covering. A magnitude is just the amount of something, so how big or how much something is. Then we have a scalar, which is a quantity that only has magnitude or an amount. A vector is similar to a scalar, however, it has a magnitude and a direction. So if I said if I'm moving 30 miles per hour, that's a scalar. It only tells me how much I'm moving or how fast I'm moving. If I say I'm moving 30 miles per hour north, then that gives me a magnitude and a direction. Clock time is when something happens. Recording this video at 7:46 a.m., so that's when I'm recording it. In physics, we use symbols to shorten down a lot of these. So we'll use the symbol t and the unit seconds. So when something happened at 14 seconds after the start time. Meanwhile, there's a time interval, which is how much time it takes for something to happen. It took the car 14 seconds to go from the starting point to the ending point. So it's how much time. The symbol is the Greek letter delta. That's this little triangle guy here. Delta t. That delta just means change, just like in math class. And what change means, it's from the very end to the very beginning. And again, we're going to use units in seconds. Position is where an object is located. We'll use the symbol x when it's a horizontal position, or if we're moving up and down in the vertical position, we're going to use y. We'll measure position in meters. It's kind of not intuitive sounding, but you'll see how it works as we work through it, and it actually works out quite nicely. The distance is the length one path is followed as it moves from one place to another. So what that means is if I go out and I walk 3 miles, and then I turn left, and then I walk 4 miles, then the total distance I've traveled is 7 miles, 3 plus 4. The symbol that we'll use for distance is d, or we could use L for length. Unit will be measured in meters. Displacement is the straight line distance. So if I walked 3 miles, and then I turned left, and then I walked 4 miles, my total displacement would be the straight distance between those 2 points. And if you drew that out as I was saying it, then you'll see that it's going to make a right triangle, and you can just connect the dots, and there you have it. A right triangle, and the hypotenuse is going to be 5 miles. The symbol for displacement is going to be delta x if an object moves horizontally, or delta y if an object moves vertically. And we're going to use meters to measure displacement. A little bit more. Speed is the rate at which the length of an object's path changes. Velocity is the rate at which an object's displacement changes with direction. So the symbol is v for both speed and velocity. So speed is just the scalar quantity. It's just the rate that the length of the object's path changes. And then velocity is the rate of the object's displacement changing. So it includes direction. And the units for speed and velocity, we're going to use the meters per second. Average speed is the total distance an object travels divided by the total time taken over an entire trip. And then we have average velocity, which very similar, but it's going to be the total displacement of an object divided by the total time taken to move along over an entire trip of motion. Instantaneous is how many meters an object is traveling every second at one specific moment in time. So it's how fast you're going exactly, just like on your speedometer. It tells you you're going 30 miles an hour. And instantaneous velocity is including direction. And that's all for this one.